Dear students, in the previous session, we have discussed the methods of disinfection and disinfectants and chemical disinfectants available for use in sericulture. We have also discussed about various bed disinfectants. In this session, let us discuss on different methods followed for silkworm egg incubation, practices for chalky mulberry in tropics and chalky worm rearing method. You all know that the life cycle of Bombyx mori demonstrates the most advanced form of metamorphosis termed holometabolous, the serial progressions of 4 distinct stages of development to complete one generation of the species, that are ova or egg, larva, pupa and imago. The number of generations per year or season depends on the volatilism of the silkworm strain and variables including temperature. Volatilism is when some members of a species enter a hibernation like period of diapause while others do not. Under natural conditions, silkworm strains producing one generation per year are univolatile. After the removal from cold storage, egg in diapause begin final development until hatching about 2 weeks later. About 6 to 8 weeks after the start of ova incubation, one generation of Bombyx mori is complete. Now, let me explain the incubation methods. The success of sericulture depends on quality of silkworm eggs. Therefore, management of seed production, transportation and incubation play important role on overall return. To produce quality seed or eggs, it is very important to adopt scientific methods of egg production right from the seed crop rearing to egg incubation. In case of egg incubation, the ideal temperature is 25 degrees centigrade and relative humidity is 80%. The devices used are Chawki tray with paraffin paper, earthen incubation chamber, double walled chamber. The egg sheets has to be spread out as a single layer in a Chawki tray over a wax paper surrounded by wet foam pads. This incubation is a prominent step in protecting the silkworm before rearing. After the eggs have been hatched or removed from the storage, the environment upon which they are protected has the greater influence on development of their embryos, health of the larvae, mortality of the silkworms and so on. So, incubation is also known as seed warming, in which the activated silkworm eggs are protected in proper temperature and environmental conditions so that the embryos can develop normally and egg hatch uniformly. So, it is very important to know the incubation time to ensure the growth and preservation of mulberry leaves that coincides with the growth and development of the silkworm. The determination of incubation period depends on larvae period and time required for incubation. So, let me now describe the chalky worm rearing. What is chalky rearing? Rearing of young age silkworms up to second molt is called as chalky rearing. This stage of larva requires ideal environmental conditions, tender mulberry leaves. The robust growth and development of chalky larvae make them resistant to diseases and more stress tolerant during the later stages of development. Silkworm eggs should be procured only from licensed seed preparers which are tested and certified as disease-free layings. Under normal recommended cultivation practices of mulberry, 250 to 300 disease-free layings can be brushed per crop per acre. The silkworm layings have to be transported in egg carrying boxes during cooler hours of the day from the grainage center to the place of rearing. The transportation of egg boxes avoids exposure of layings to extreme temperatures and the humidity. During this incubation period, care is essential and it has to be taken into consideration to preserve the layings in a disease-free environment with high relative humidity of more than 80% and temperature should be of 24 to 25 degrees centigrade. The embryo inside the eggs grows healthily, utilizing the reserved food materials in the yolk and prepares to hatch on the 10th day of egg laying. So, to maintain the ideal temperature, humidity and hygiene during the incubation, several techniques has been recommended. Let me list out those techniques. Initially, the layings after procuring from the grainages are spread in a single layer on a paraffin paper spread rearing trays. Wet foam pads are to be placed all around the layings and covered with another paraffin paper. This helps to provide ideal temperature and humidity. Another technique is a wet earthen pot. Well-baked earthen pot with wide mouth is filled with 2 to 3 kilograms of wet sand and egg sheets are tied to a stick and hung above the wet sand bed. Another technique is buried earthen pot method. A common round pot having a wide mouth is buried in clean sand up to the neck and sand is made wet. In both the above two cases, the sand is kept wet one day prior to incubation for preconditioning. So, the laying in sheets are tied to a rod or a stick and hung inside the pot and the pot is covered with a wet cloth. Now, the temperature is reduced to 5 to 10%. Eggs are incubated up to head pigmentation stage and then it is transferred to a black box. Another technique is a double walled chamber method. Here, the chamber is constructed using brick and mortar. A gap of about 3 cm is left in between the inner and the outer wall, which is filled with loose and clean sand. The standard size of the outer wall is 6 by 4 by 3 cm, while that of inner wall should be 4 by 2 by 3 cm. And this chamber should accommodate 5000 to 6000 disease-free layings. In case of incubation for loose eggs, it relates to the process where the loose eggs are being transported in a loose egg carrying box and then incubated in loose egg incubation frame. These eggs should be incubated in frames made up of 2 cm thick plastic or wood. The outer frame is 36 by 24 cm and the bottom inner frame is 32 by 20 cm and it fits perfectly in the outer frame. These loose eggs are spread uniformly on the inner frame covered with a tissue paper and outer frame is fixed to hold the tissue paper. Then these frames are placed in a rearing tray and covered with the paraffin paper. Each frame can hold 50 disease-free layings of loose eggs, that is of about 20,000 eggs. Another technique for uniform hatching of eggs followed is black boxing of eggs. This technique is subjecting developing eggs to a totally dark condition to synchronize the circadian rhythm of the silkworms. This ensures uniform synchronized hatching of eggs. Black boxing should be done on 8th or 9th day, that is on the onset of eye spot or blackhead stage. A long paper cover that is made from a black craft paper is used for this purpose. In each cover, 12 by 9 cm size, 250 disease-free layings packed 5 tissue paper covers containing 50 disease-free layings, each is placed inside the black cover. The cover is then clipped and kept in the rearing tray surrounded with wet foam pad and covered with another paraffin paper. On the day of hatching, that is at 7 or 8 am, the covers are opened and layings are exposed to mild light. So, within 2 hours, all the eggs will start hatching. For acid treated bivoltan eggs, a minimum of 60 hours of black boxing, and for hibernating eggs, minimum of 72 hours of black boxing is required. Now let me explain the practices for chalky mulberry gardens in tropics. The silkworm species Bombyx mori is a monophagous and highly domesticated insect. The qualitative and quantitative requirements of the feed for silkworms differ at different stages of larval period. It is generally established that young age silkworms require mulberry leaf of higher succulence, moisture and nutrient contents, but the late age worms feed on coarser leaf with less moisture content. The quality of leaf used for young worms is of greater relevance in view of the influence of chalky rearing on the late age silkworms and ultimately the success of the cocoon crop. Hence, the production of succulent and nutrient leaf attains greater significance in establishment of the chalky rearing centers. On the other hand, growth of chalky mulberry plants should be monitored in such a way to reduce the coarseness and rate of maturation of mulberry leaf, thereby avoiding the wastage of the biomass that is produced by such mulberry gardens. Keeping in view the delicacy of young age silkworms and their contribution towards the success of the cocoon crop, the said technology has been developed at the Karnataka State Sericulture Research and Development Institute with suitable cultural practices like spacing, manuring, irrigation, leaf harvesting schedules, apart from selection of suitable superior mulberry variety, and then the pruning schedule for the establishment and maintenance of exclusive chalky mulberry gardens, and a wholesome package for economization of the chalky leaf production. So, by adopting this technology, about 10,000 kilogram chalky mulberry leaf harvested from 1 acre can be obtained. The leaves are nutritious with about 76 to 78% of water content and 24 to 25% of soluble proteins, 9 to 12% of soluble sugars, which are very crucial for the healthy growing of the young silkworms. We have seen that in case of pruning, annual basal cut at 30 centimeter above the ground, preferably during the onset of the monsoon, following the first base cut and third leaf harvests at an interval of 15 days. First middle pruning at 60 centimeter above the ground level has to be followed. Following this, 3 leaf harvests also can be made. Again, the same sequence may be followed. Totally 2 base cuts and 2 middle cuts done yearly. After about 20 days of each pruning, weak branches can be removed. In case of a light sandy loam soil, irrigation at 7 to 8 days interval may be necessary, while in heavy clay loam soils, irrigation at 8 to 10 days interval may be found adequate. And it has also been estimated that 1.5 to 2 acre inches of water per irrigation is required for mulberry. To save the irrigation water, micro irrigation system also can be suitably adapted. Several advantages are there following the pruning method techniques in chalky rearing. So, they are: by the adoption of annual pruning, schedule of 4 prunings and 12 leaf harvests, higher leaf yield of about 10,000 kilograms per 0.4 hectare per year can be obtained, and 60,000 disease free layings can be brushed per year at the rate of 15 kilograms chalky mulberry leaf per 100 disease free layings. An increase in number of harvests and maintenance of vigor of the plants may suitably adjusted by adoption of yearly 4 prunings and 12 harvest schedule. So, this schedule can be easily practiced by private chalky rearing centers or large scale sericulturists. Good quality chalky leaves for every harvest could be produced at an interval of 15 days. The leaves will be rich in water content and nutrients, and when fed to young silkworms, their growth will be the best. If a chalky mulberry garden or a plot is divided into 2 plots or units, and recommended package of practices are followed, yearly 24 chalky leaf harvests can be obtained to facilitate regular brushings once in 50 days at chalky rearing centers. So, the advantage of this package of schedule is, other than obtaining suitable leaf for chalky rearing, chalky leaf can be produced throughout the year, continuously coinciding with the brushing programs. Conducting late age silkworm rearings with good chalky reared worms will lead to a good cocoon production. Some precautions are to be followed, and they are adequate irrigation and recommended inputs to be ensured. The cardinal point is shoot tips should not be removed during any leaf harvest. Plant protection measures can be taken only after 2 base cuts and 2 middle cuts and 15 to 18 days before the leaf harvest for brushing. Now, let me explain the nutritional requirement or feeding for chalky rearing. Chalky worms should be fed with succulent mulberry leaves rich in nutrients and moisture content, with a water content of 80%, with a protein content of 27% and carbohydrates of 11%. Separate chalky garden with a superior mulberry variety like KNG or Equinox are maintained by providing the irrigation and inputs such as farmyard manure and chemical fertilizers in the recommended dosage, that is farmyard manure of 40 metric tons and nitrogen, phosphorus and potassium in the ratio of 300, 150 and 150. Select first glossy leaf from the top of the branch for first feeding at the time of brushing, and with the advancement in larval age, the first, third to fourth tender leaves can be used. So, the leaf harvest must be done in the morning and in the evening, and the leaves has to be preserved in a cool place covered with wet gunny cloth. In dry season, we can sprinkle water over the leaves and preserve them under wet gunny cloth. Chopped leaves should be fed to worms for uniform growth. 3 feeding schedule, that is at 6 am, 2 pm and 10 pm should be followed. Stop the feeding when above 90% of the worms settle for molt and resume when 95% of the worms comes out of the mold. 30 minutes before the feeding, the paraffin or polythene are removed, and after feeding, the rearing beds are again covered with the polythene sheets. The size of the leaf fed should be 1.5 square centimeter, and in the first stage and increase to 3 square centimeter as worms advance in age. Size of the leaf should be reduced when worms start settling for molt. With regard to bed cleaning, only 2 cleanings are recommended during second stage and no cleaning in the first stage. Cleaning nets are applied on the bed. Chopped leaf is fed to the worms and the worms start crawling through the net, and after 2 hours worms are transferred to another tray. If cleaning nets are not available, the topmost layer with worms must be taken with a feather. Coming to the chalky rearing, the concept is to raise a healthy stock of silkworms. The system of chalky rearing must be quite effective. So, the maintenance of optimum temperature or optimum relative humidity, feeding of nutritious tender leaves, maintenance of absolute hygienic condition and rearing chalky worms experienced persons are needed. Presently, most of the farmers are engaged in self-chalky rearing. However, cooperative chalky rearing have the following advantages over the existing technology. They are: ensuring uniform embryonic growth and good hatching, minimizes the missing larval resulting in higher larval population, robust and disease-free growth of the worms, prevention of crop loss and stabilization of cocoon crop, minimization of pest and disease outbreak by synchronization of crops. Crop monitoring is also easier and effective. Effective utilization of saved labor and time for other activities. High cocoon yield of good quality at reduced production cost, and by adopting the chalky rearing technology, farmers get 5 to 6 kilograms more cocoon yield compared to doing self chalky rearing. So, in addition to cocoon yield, Farmer will be free from rearing activities for about 10 days and the cocoon production cost reduced and crops will be synchronized. The technology develops cooperations among the farmers and this has the social impact on villages. Chawki rearing centers are the backbone of sericulture industry and all the important technologies can be advocated through these Chawki rearing centers. And coming to the marketing of cocoons also can be linked through Chawki rearing centers. Sometimes the Chawki worms are also directly distributed to the farmers. So, how it could be distributed? Worms in the tray can be rolled along with the punched paraffin or old newspaper at the base and the top and the ends are closed and stapled. Worms should be transported to the rearer's house during the morning hours and fed immediately with the fresh leaves. For this we have to follow some precautionary measures during the rearing of young larvae. Let me list out. They are: before entering the rearing room where Chawki worms are reared, hands should be washed. Separate footwear should be used inside the rearing rooms and silkworm litter should not be thrown in the rearing room. Rearing room should be kept clean and tidy. Avoid touching the worms. Another technique is isolation chamber. The young age rearing is the most important activity in the silkworm rearing and a good Chawki is the key for the successful crop. However, most of the farmers do not have a separate Chawki rearing room. So, realizing this prevailing situation, an isolation chamber has been evolved. This helps in providing all the required conditions to a larger extent in the farmers' rearing houses and Chawki rearing centers. It is observed that when Chawki is raised in such isolation chambers, there is an increased larval and cocoon weight with a better survival rate and therefore leading to higher yields. The isolation chamber can easily satisfy the average farmer as it can easily be accommodated inside his dwelling house and this chamber can be made either with wood or brick masonry. The construction details of a model isolation chamber for a unit of 300 disease-free layings up to second molt are explained as below. That is, the isolation chamber can easily satisfy the average farmer as it can easily be accommodated inside his dwelling house and it can be made either with wood or brick masonry. And during the winter season, to increase the temperature, a 2 kV blowing type heat convector can be fitted to one of the ventilator in the bottom of the chamber and the heat convector is connected to a thermostat to regulate the temperature. But during the summer, humidity of the chamber is increased by keeping water in a wide tray on the floor in addition to the use of wet foam pads around the beds if necessary. Temperature and humidity inside the chamber has to be maintained properly. The maintenance of uniform temperature and humidity is easy inside the chamber mainly because of the restricted area. So, when heater is used to increase the temperature, the power consumption is very less as the heater is on only for few hours per day as compared to the continuous functioning outside the chamber. Further, under non-manipulated condition, the temperature is uniform without much fluctuation inside the chamber, which is more congenial for the growth of the larva as compared to wide fluctuations outside. It is also observed that humidity is always on the higher and uniform in the chamber as compared to the outside. So, isolation chamber is better to use in the farmer's field itself. Then maintenance of leaf quality is very important because the loss of moisture of the cut leaves used for Chawki rearing is very less inside the isolation chamber mainly because of prevailing high humidity. As a result of this, the bed life of the leaf is better which enhance the leaf utilization efficiency as reflected by the increased Chawki larval weight. Inside this incubation chamber, proper aeration or ventilation is also achieved through lower and upper ventilators. One of the lower ventilators is closed when the other is fitted with blowing type heater, while upper ventilators are to be kept open by of its size during the beginning of the first instar. As the larvae grow gradually, upper ventilators are opened to of its size by the end of the second instar. Now keep both the lower and the upper ventilators open when the heater is not used. All ventilators should be fully opened half an hour before feeding to facilitate the bed drying, so also during molting to reduce the humidity to keep the bed dry. Unnecessary opening of the doors should be avoided since it affects the uniform maintenance of temperature and humidity and also increases the chance of contamination of dust and pathogens. In scientific cultivation of mulberry and adoption of new technologies in silkworm rearing plays an important role in the production of quality raw silk. So, the larval duration in the life cycle of the silkworm ranges from 24 to 28 days and it comprises of 5 instars and 4 moulds. Rearing of silkworms from 3rd or 4th instar up to the spinning stage is called the late age worm silkworm rearing. During this period, the silkworms consumes more than 94% of total mulberry leaves required and 133 times increase in body size and 125 times increase in body weight and 1000 times increase in the silk gland weight from the time of hatching. Since the late age silkworms are sensitive to high temperature and humidity, scientific rearing methods and rearing skill method are necessary for achieving maximum growth and survival of the larva, thereby increasing the cocoon yield and silk production. So, students, in this session we have discussed about the incubation methods, practices for Chawki mulberry in tropics and Chawki worm rearing method, and we have also discussed in detail about the incubation of loose eggs. So, to summarize, to produce the quality seeds or eggs, it is very important to adopt scientific methods of egg production right from the seed crop rearing to the egg incubation. In case of egg incubation, the ideal temperature we have to maintain is 25 degrees centigrade and relative humidity as 80%, and the devices that are used for Chawki tray with paraffin paper, earthen incubation chamber, double wall chamber, and the egg sheet should be spread out as a single layer in a Chawki tray over wax paper surrounded by wet foam pads. Incubation is hence a prominent step in protecting the silkworm before rearing, and after the eggs have been hatched or removed from the storage, the environment upon which they are protected has greater influence on development of their embryos, health of larvae, mortality of silkworms and so on. So, young age rearing is the most important activity in silkworm rearing. A good Chawki is a key for a successful crop. However, most of the farmers do not have a separate Chawki rearing room. So, realizing the prevailing situation, an isolation chamber has to be evolved, which helps in providing all the required conditions to a larger extent in the farmers rearing houses and Chawki rearing centers. It is observed that when Chawki is raised in such isolation chambers, there is an increased larval and cocoon weight with better survival rate and therefore leads to higher yields.